Hi everyone, this is Himanjali. Today my task is to find and print all the unique combinations of the numbers from an input array such that the product of the numbers in the combination equals a given target number. Let us see the problem. Let us walk through an example by explaining this problem statement. Let us take an array of 4 elements, that is the elements are 2, 4, 6, 8, and our target number is 16. This is the target number, and this algorithm explores all the possible combinations by repeatedly including elements from the in array and checking their products. If the product matches the in number, the combination is valid. By sorting and using the start index, duplicate and unordered combinations are avoided. Okay, what become the output of this problem statement is output becomes the possible combinations are 2, 2, 4 twos are 16, 2, 2, 4, 2, 8, 4, 4. These are the possible valid combinations for this output. Let us solve the problem by the following steps. The first step is taking the input and make sorting. In the first step, we start by taking two inputs. These are in array, in number. A list of numbers called in array, a target number called the in number. Next, we sort the list in ascending order. Sorting ensures that combinations are generated in a proper order and duplicate combinations are avoided. For example, after sorting the n array 2, 4, 6, 8 will become. The step 2 is backtracking. In backtracking, we use a method to explore all the possible combinations of numbers in array. Backtracking is a systematic way of trying all the possibilities by building a combination step by step and then undoing it to try other options. This contains, as it is a recursive function, and this contains the start index to control where we begin adding numbers to the combination, and the path to store the current combinations of the numbers being explored, and the product to keep the track of the product of numbers in the current combination. This is our second step. And the third step is the base cases. The backtracking functions uses two main conditions to decide what to do. The two conditions is if the product of the numbers in the current combination is equals to the innum, target double equals to the product, then the combination is valid. The second case is if the product exceeds the target. Then it is invalid function. And the fourth step is the recursive exploration. As we all of you know that what is the recursion process? The function explores the numbers in the sorted array starting from the given index. For each number added to the current combination, multiply it with the current product, recursively explore further by calling the function again. Once done, remove the last added number to backtrack and explore other options. And the fifth step, printing the results. After exploring all the combinations, if all valid combinations are found, we print each of them. And if no valid combinations is found, we print -1. For our array 2, 4, 6, 8, the output will be 2, 2, 2, and 2 to 4, 2 comma 8, 4 comma 4. Now I write the program step by step to explain how to solve this problem. The first step of my solution is we have to take the input. As the input is the first array, we have to take in the form of array. Int comma input dot strip dot split and our target element input is, and as it is the integer, you have to take an int input. This is our first input step. Input reads the string. This input reads the string only. Dot strip removes any unnecessary spaces. This is the split method, splits the string at the commas to form a list of string numbers, and map converts the list of string numbers to the integers. The list stores, this is the list method, list stores these integers in a list called inarr. The second input directly reads the target number and converts it to the integer stored as the in number. Now you have to make the input sorting. In order to make the sorting, first you have to ensure that sorting ensures the combinations are generated in the ascending order. In order to ensure that sorting, first you have to define the recursive function. You have to use a function using the def keyword, find combinations in the parameters in array comma in number. After defining the function, you have to sort the array using the dot sort method. Now the array will be sorted after calling the find combination functions. Actually, the sorting ensures the combinations are generated in the ascending order, and we have to write that function. First, we have to declare an array to store or keep the final result. Now we have to use the backtracking function in this array. As my backtracking function name is backtrack with the parameters start, path, comma product. This is my backtrack function. And in this function, the start index where to pick numbers in inarr. The path list to store the current combination of the numbers being explored. The product is the current product of the numbers in the path. And in this function, we have to write two base conditions as I said earlier. If the product equal to our target element innum, then if the product double equal to innum, then we have to use the condition that I have used out array dot append path dot copy. Why I have used the path is the stored arrays are stored in the path. that path copy is placed in the outer array. If the product equals to the target, the current combination is valid. So it is added to the results outer array. And if it does not occur, that means if product greater than innum, then return. This is our two base conditions. And next we have to use the for loop. That for loop is used for the numbers in the in array starting from the starting index. The for loop is for I in range start comma len of in array the path dot append in array of I. Okay, add the current number in array of I to the combination of the path. As the loop starts from the start, as the starts from the backtracking recursive function, and after path dot append in array of I, we have to use that we have to call the backtrack function again. That is by backtrack of, we have used the I in the place of start, because after appending the in array of I, you have to use the number I same path, and the product becomes the product into in array of I. This is the main step of this code. After multiplying the product in the first element in the in array, the product becomes the product into in array of I. This is stored, and with the possible combinations, these are stored in the path, and the path of path copy is appended to the outer array. This is our main step, and after backtracking this, we have to remove the last element which is added, and we have to backtrack with the remaining elements. This is the backtracking main purpose. Okay, after removing the path dot pop, we have to again backtrack. We have to again backtrack of the following by backtrack of 0 as the start symbol, empty path, and 1 as the product. This is the starting purpose of this array. The first start symbol is 0, and the path becomes the empty array, and the product is the 1. Okay. Then after appending all the path in the array, if outer array is present, for any combination in outer array, if it is true, then we have to print the result as print. We have to print it as array by becoming commas using the join, map, str, comma. What is the result of this loop combination? As we call a combination. If outer array is not, print -1. This is our total find combination function proceed. And after taking the inputs, you have to call the find combinations function. Find combinations of inarr, comma, innum. This is our final code which solves the problem. Firstly, it generates with this code by taking the example 2468. After sorting the example 2468 will become the generated combinations of this are 4. First it starts with the start symbol as 0 and the path as empty array and the product is 1. By taking the element 2468, the first number is 2 and the path becomes empty array. After becomes 2, the 2 is multiplied with the product as 1 and the 2 is entered into the path. The path is copied into the, if the path is really the product of the path is equals to the in number, then it is added to the outer array. After adding all the arrays, the output will be printed by calling this function. This is our final code of the problem. Now we have to run the code. The test cases are become successful. And the steps, I have to again repeat the steps. The first, we have to take the input of the array and the target element. The numbers are first converted into a list and sorted. In the first step, we have to use dot sort method and we have to use the backtracking function. As in the two base conditions, if the product equals to the target element or the product exceeds the number. If the valid combinations are exist, we print them, otherwise we output them as -1. The backtracking methods, if the product equals to the target, we save the current combination. If the product exceeds the target, we stop exploring the further. We continue to add numbers from the array, multiplying their product and backtrack after every recursive call to explore other possibilities. And this is the final output of the problem. This algorithm can be used for solving problems like finding combinations in subsets, generating unique product combinations, or any other similar tasks. Okay, thank you.